Kavya,
Hi, this is Shailaja.
and today we are gonna talk about the ICP-09.
Where our task is to build a regression model for the data set.
And for that, one second, sorry. Yeah, here we have imported all the required libraries, and from upload files.upload method, we are uploading the file that is house
How-
sale.
So here you can see house.csv we have uploaded. After that, we're just reading the
We
uploaded
can upload
facility.
any data set here.
Yeah. After that, we are just reading the house data set and printing the first five records of those data sets. Here we can see the data set is displayed here with multiple columns like price, bathroom, square feet living. So these are all the columns which are in the house.csv file.
And here just we are giving the shape for the data.
After that, we are just using this info method. This info
We are
method
just
tells
printing the
us,
information of the data.
so it tells what are the number of columns and data type of those columns and so on. As you can see, there are a lot of columns here. Next, we are just using this describe method to just get the statistical information of the data for the numerical columns. So as we can see here, the count, that is mean, standard deviation, minimum, maximum. So these are all the statistical parameters which it has calculated for these columns, which are numerical columns. After that, we are checking if there are any null values in our data set. As we can see, there are no null values. And now we are plotting the price column with the other variables or columns, because since there can be dependent and independent variables, where price is the variable which is predicted based on the various multiple columns. For example, here we can see that we have taken x as square feet living and y as price. So the price is fixed variable, and the other variables are, we are just changing those. So price is dependent on those variables. Here we can see there are three plots. One is for square feet living, and is for a year built and renovated. So based on this, the price will vary. So next we are plotting the correlation heat map for all the columns. Here we can see there is a lot of data. And after that, we are defining a dependent and independent variables. That is, to split the training data and testing data, first we need to know what is x and y. So the x is square feet living, the main column which we've taken. There is, now we are taking only one variable, that is square feet living. Next we are taking the fixed variable as price. So next we are just splitting it after defining those variables. Training data as 70%. We are now defining the regression model and fitting the
And fitting
model.
the model, and here we are predicting the values.
After
And
predicting, we are just plotting the regression line for training data as well as testing data. Here we are just doing the train data plot, and this is the data has plotted like this. Next, we are just plotting it for the test data. And after plotting it, after seeing the difference, there is not much difference here. So next we are calculating the intercept. So that is the model.intercept method we are using. Here we can see there is a negative intercept for the model and the slope is positive. Next, we are calculating matrix calculation like root square. So the root square for the x and y variables. Here the root square error, that means that we've got 0.49, which means that it is 49.28% of the variance in price. So that is, so when a square feet feature is given as input, so the variance is nothing but the uh, how the price is changing based on the square feet feature, is it is like 49.28%. It is dependent based on those square feet feature. It is saying that the root square. After that, we are calculating SSC, which is sum of squared error. It tells us the difference between the observed value and the predicted value. And also we have calculated MSC, that is mean square error, which tells how close are the points to the regression line. That is, it calculates the distance of the point from the regression line, and it gives us the distance. That is called the mean squared error. So yeah, this is all about the linear regression we have performed and the matrix calculation. Thank you.
thank you.